Hello students. Uh, in this video we are going to look at the next and the last topic of motion in two dimension, that is circular motion. A body is said to be in circular motion if it moves along a circular path. The circular motion is classified into two categories, that is uniform circular motion and non-uniform circular motion. In uniform circular motion, the body moves with a constant speed. So a body moving along a circular path with a constant speed is said to be in uniform circular motion. So even in uniform circular motion, there is a change in direction of velocity. And because of change in direction of velocity, there is an acceleration. So from the figure, you can see that the initial velocity and final velocity are, let's say, at an angle difference theta. If the angle is very small, I'll call it as d theta. Then I can say change in velocity delta v equal to how much? A into dt. That is acceleration into small time. Now delta v equal to how much? Because it is a dt. That is delta v, and what is the angle that it is making? From this I can write delta v is equal to a dt. From the figure I can write this to be equal to how much? R d theta. Now what is R? R is equal to v, so I can write it as v into d theta, where v is velocity and d theta is small change in angle. So we have seen delta v equal to how much? We got this to be v d theta, where v is magnitude of velocity and d theta is change in angle. Now delta v, what is acceleration? Acceleration is delta v by dt. So that can be written as v d theta by dt. Now d theta by dt is rate of change in angular position, so that can be written as omega. Now we know omega equal to how much? V by r. So substituting that, I'll get v into v by r, that is equal to v square by r. So the acceleration that is acting on a particle in uniform circular motion is v square by r, and it is always directed towards center of the circular path, and hence it is also known as centripetal acceleration. Now let's look at non-uniform circular motion. So non-uniform circular motion will have both centripetal acceleration as well as tangential acceleration. The reason for that is in non-uniform motion, circular motion, a body moves with a changing speed. So there is a change in direction of velocity as well as a change in magnitude of velocity. Now we have seen that what is AR? Radial acceleration is given by what? Radial acceleration is v square by r. Now this is called radial or centripetal acceleration, which is responsible for change in direction. Now the next thing that we have is tangential acceleration. Now what does tangential acceleration do? Tangential acceleration changes the magnitude of velocity. So I can write tangential acceleration at equal to, I'll write dv by dt. So change in magnitude of velocity by time. Now how do I find it? So I can write tangential acceleration is equal to r into alpha, where alpha is angular acceleration. And what is angular acceleration? It is rate of change in angular velocity. So alpha is equal to how much? D omega by dt. So what do we have? We have tangential acceleration is given by r alpha, where r is radius, alpha is angular acceleration, and radial acceleration is given by ar, which is v square by r, which we have just found it out. Now from these two things, the total acceleration would make some angle theta. So if this is theta, then what is tan theta? Tan theta would be equal to at by ar, right? So if we can find out at is r alpha, ar can be written as r omega square. So if I cancel r and r, I'll have alpha by omega square. So theta equal to tan inverse of alpha by omega square. This is what is the angle at which the total acceleration acts with the radius of the circular path. Now, if I want to find the magnitude of net acceleration would be under root of ar square plus at square. So this is the net acceleration. So that means what? In case of non-uniform circular motion, the acceleration is not directed towards the center like in uniform circular motion. And because there is change in magnitude of velocity as well as direction of velocity, we have a radial acceleration which is responsible for changing direction of velocity, and we have tangential acceleration which is responsible for change in magnitude of velocity. So these are very important points that you have to remember. Radial acceleration can only change direction of velocity, and tangential acceleration can only change magnitude of velocity. So say there are some situations, let's say I take a situation where radial acceleration is not equal to 0 and tangential acceleration equal to 0. This will imply uniform circular motion, UCM. If radial acceleration is not equal to 0 and tangential acceleration is not equal to 0, this would imply non-uniform circular motion. Right. Now let's look at other cases. If radial acceleration is 0 and tangential acceleration is not 0, then this will imply linear motion. Right. So these are the various kinds of motion that I would encounter depending on whether a given acceleration, radial or tangential acceleration, is 0 or not. So this is what is there in circular motion. Hope you could follow this. Thank you very much.